My name's Ian Gibson, and I'm the Scientific Director for the Fraunhofer Project Centre at the University of Twente. Now, I'm going to be talking to you today about taking AM seriously, the move from prototyping to manufacturing. Case studies that we're using today are examples drawn from our experiences and activities working for a variety of customers across multiple projects. They do not represent our work for any one customer or set of customers. In many cases, facts have been changed to obscure the identity of our customers and individuals associated with our customers. As I mentioned, I am the Scientific Director for the Fraunhofer Project Centre, which is based in the Netherlands. It's the only Fraunhofer Centre in the Netherlands. And as you can see from this map, there are a variety of Fraunhofer centres located around the world, not just in Germany. Our centre is a partnership with the Institute of Production Technologies in Aachen in Germany, and we've learnt a lot from working with them and are currently working more and more towards developing our own activities, also in conjunction with Saxion University of Applied Sciences. As I mentioned, this presentation is based around additive manufacturing in industry. And we work very closely as well with Additive Industries, who are based in Eindhoven in the Netherlands. And they have developed their Metal Fab 1 machine, which we have one of those. And this machine is very much focused at trying to address the issues of migrating from a laboratory type environment to an industry environment, where the machines are working more and more closely with other manufacturing technologies and machines. Because a lot of industries are now interested in additive manufacturing for manufacturing purposes. Automotive started off by being more interested in rapid prototyping and have moved and migrated across to using additive in all stages of their product development. And their primary goal is to speed up the time to market for their products, because they're in a very highly competitive environment. Aerospace industry is more interested in optimizing their designs so that they can be as efficient as possible. And that means tuning the geometry of the parts so that they work in an optimized fashion, for lightweight in particular, so that they can be incorporated into aircraft using less fuel. Medical industries are interested in additive manufacturing for other purposes, primarily looking at being able to capture the data of individuals for medical devices so that they can customize those devices. Additive manufacturing is different. Industry is looking towards using additive manufacturing primarily because they want to change their something in their organization. Either they want to change the product designs, they want to change the processes that are used to manufacture those parts, or their supply chain, or indeed all three. And when they want to do that, they want to apply those changes in an effective way so that they can make shrewd investments in the technology and get the best out of those technologies. So they work with the Fraunhofer Project Centre to try and address those issues and to answer key questions that they need to have answers for in order to move forward. And so what we do is work with them to create effective business cases for them, to help with their training and knowledge transfer, and also to create plans for them for implementation of the technology. And we can do this by creating effective demonstrators which can illustrate a lot of these problems for them. Because, we all know what additive manufacturing is these days, but we need to look at it much more closely. Particularly metal additive manufacturing, which is really dedicated towards going onto a shop floor. And when we look at how parts are built, they get there are small distortions which occur in the parts, and everybody knows that parts coming off an additive manufacturing may have surfaces that are inadequate for certain engineering purposes, and they need to have therefore machine finishing. Furthermore, the distortions that occur in the parts affect tolerances, and therefore features may not be located as precisely as are needed. And therefore, additional post-processing of the parts is required in order to get them to their peak performance. And we've learned a lot of this by working with organizations, companies like Aeronamic, which is an aerospace company. They had a requirement to be able to create parts for one of their clients. And they make turbine housings, and what we can see there on the right is a typical design of theirs, made in Inconel, which is a very hard to process material. It's very good for aerospace applications. And if you look at all the features on that design, you can see that they need to be very careful about the tolerances of all the components that are going to be located in conjunction with that design. And that's just one problem and one industry. And there are many others. And if we look at this curve, we can see that those are going across a variety of different sectors and are a variety of different levels of maturity. So if we want to be helping these companies, we need to understand a lot about what type of technologies they require and how much knowledge they need to gain in order to get into additive manufacturing for their particular applications. Furthermore, there are other technologies which have to be understood as well. It's not just additive manufacturing, but all the software that goes along with it, all the other technologies that combine with it. I mentioned about post-processing, so CNC machining. We need to understand what it can offer, what metrology equipment is required, how it fits within the overall data structure of that organization. Because a lot of these industries are working in this sort of Industry 4.0 framework. And so they are very keen to understand how their data is used within their organization. And additive manufacturing can be seen to have been evolving all along with Industry 4.0. To the extent that it might be the end of Industry 4.0 and moving into Industry 5.0, being able to create parts on demand for users without any manufacturing industry involved. But we're a long way from that, and we need to therefore carry on a long journey yet before we can get to that point. But what we can be clear about is that additive manufacturing is here to stay, but there's still a long way to go. That AM is evolving to match industry needs, and therefore we need to understand how it integrates in the larger framework around Industry 4.0. And then what we can say is the Fraunhofer Project Centre can work with you. So let's travel that journey together.